Now we're going to connect an engaging math activity, putting math on the map, to STEM careers. This is just an example of what teachers can do in their own classrooms. This activity uses the math skills of creating scale drawings and making measurements. Imagine this scenario. Deep in the grasslands of South America are two ecology research camps. Both camps need to be supplied with water. The researchers plan to put a pump on the bank of a nearby river and use pipes to carry water from the pump to the two camps. To reduce damage to the environment and keep costs low, the researchers want to minimize the total length of the pipe used. This drawing shows one possible location for the pump. The dotted yellow lines represent the pipes that would run to both camps. What do you think the best location for the pump is in order to minimize the length of pipe required to provide water to both camps? Record your predictions on the Putting Math on the Map investigation worksheet. Discuss how the optimal location can be determined. Use words, numbers, and pictures to explain your thinking. One method to determine the optimal location for the pump is to make a scale drawing of the scenario with the pump placed at selected points along the riverbank. Then measure the total lengths of pipes for each pump location. Another method is to try to find a geometric solution to the problem. Since it's not possible to draw the Putting Math on the Map scenario at its true size on paper, we need to make a scale drawing. A scale drawing shows a real object or scene with the dimensions all reduced or enlarged by the same scale factor, called the scale. Scale drawings and models are useful for representing objects that are either too large or too small to be observed directly. For example, a scale map of the United States can fit on a piece of paper small enough to fit in your pocket. A scale drawing of a human brain cell can be made large enough to show features that are too small to see, even with a microscope. Common Core state standards for 7th grade say students should be able to solve problems involving scale drawings of geometric figures, including computing actual lengths and areas from a scale drawing. Students build up to this grade 7 standard beginning as early as 3rd grade, when they begin to draw a scaled picture graph and scaled bar graph to represent a data set. Let's make a scale drawing of the river and the two research camps on the 1 centimeter graph paper. Use a scale where 1 centimeter represents 100 meters. First, find the length of the river in our scale drawing. Look at the picture of our scenario. The river is 1,200 meters. Use the scale 1 centimeter represents 100 meters to convert the length of the river, 1,200 meters, to the correct number of centimeters on our scale drawing. The scale can be represented as a ratio, 1 centimeter to 100 meters, or 1 centimeter over 100 meters. If x centimeters equals 1,200 meters times 1 centimeter over 100 meters, then x centimeters equals 1,200 centimeters over 100 centimeters, equals 12 centimeters. So, to represent the river, draw a horizontal line 12 centimeters long on your graph paper. Since Alpha Camp is 600 meters from the riverbank and Beta Camp is 200 meters from the riverbank, Alpha Camp is 6 centimeters above the left-hand end of the river on the scale drawing. Beta Camp is 2 centimeters above the right-hand end of the river. Draw these lines on your graph paper. To create scale drawings, you need to understand fractions and ratios. In our scale drawing, the scale is 1 centimeter to 100 meters. The first number refers to the length of an object in the scale drawing, and the second number refers to the length of the real-life object represented in the scale drawing. The proportion looks like this. Length of drawing over real length equals 1 centimeter over 100 meters. A proportion shows the relationship between two ratios. Now that you have your scale drawing started, follow the directions on the Putting Math on the Map activity sheet to finish your scale drawing and investigate the question, what is the shortest path?